Welcome back to Tiger Paw Academy. This lesson is on 6.2, Logarithms. Let us recall back to the lesson on 6.1. In that lesson, we learned that we could find the inverse of an exponential function by exchanging the x and the y values. The initial y values became the new x values and vice versa. Therefore, an exponential function has the formula of y is equal to b to the power of x, while its inverse has the formula of x is equal to b to the power of y. Logarithmic functions are actually the inverses of exponential functions. In logarithmic functions, we are trying to find the exponent to which a base must be placed in order to get a certain value. That exponent would have been the x value in an exponential function, but it is now the y value of a logarithmic function. The general formula of a logarithmic function is y equals the logarithm of x to the base. Because of this relationship, any exponential function can be written as a logarithmic function. For example, the general formula of an exponential function is y is equal to b to the power of x. In logarithmic form, this would be x equals the logarithm of y to the base. In exponential form, we are trying to find the value when placing a base to a certain exponent. On the other hand, in logarithmic form, we are trying to find the exponent instead. There are a few restrictions to the variables and logarithms. The base of a logarithm cannot be a negative number, because a negative base with a non-integer exponent would give an infinite number of solutions. The base of a logarithm cannot be 0, because the value is undefined, considering that we can't place anything to the power of 0. Lastly, the base cannot be 1, because any value to the power of 1 gives 1. Common logarithms have a base of 10, which is not necessarily included in the formula. If the formula does not have a base, we assume that the base is 10. So let us do some examples. Here we have the exponential equation 16 is equal to 2 to the power of 4. We know that the base is 2, the exponent is 4, and the value is 16. In logarithmic form, the y value is the exponent, and the x value is the y value of the exponential function. Therefore, in logarithmic form, the equation would be 4 is equal to the logarithm of 16 to the base of 2. In the next example, we are asked to write the logarithmic equation in exponential form. The equation is 3 is equal to the logarithm of 64 to the base of 4. We know that the base of 4 must be placed to the exponent of 3 to get 64. Therefore, the exponential form would be 64 is equal to 4 to the power of 3. In the last example, we are asked to evaluate a logarithm. The logarithm of 81 to the base of 3 is equal to an unknown number. We know that 3 must have a certain exponent to get that value of 81. To find that exponent, it is easier if we write the equation in exponential form. The equation would be 81 is equal to 3 to the power of x. Therefore, 3 to the power of 4 gives 81, so x is equal to 4. That is all for 6.2. Thank you for watching.